Hi everyone, I am Dr. Surjit Singh. Today I'll talk about the Leetcode problem, split array largest sum. Let us begin. We are given an integer array and an integer k. We are to split array into k non-empty subarrays such that the largest of the sums of these subarrays is minimized. The solution with dynamic programming is possible, but if we use binary search, we have an improvement in both time and space complexities. We are given an array named nums, and k is the number of subarrays in which we split the array such that every subarray has at least one element. We then find the value of the largest sum of these elements of these subarrays, and we need to find the minimum of all these largest sums. 18 is the largest of all the elements. Even if the subarray that contains 18 has only one element, the sum of the elements of this subarray is 18. So the highest value of the sum of elements of the subarray cannot be less than 18. Therefore, we make 18 as the initial low fence for the binary search. Highest value of the sum of the elements of the subarray cannot be more than 50, which is the sum of all the elements of nums. We fix this as our initial high fence for binary search. The actual result will lie between low and high. To perform binary search, we run a loop while low is less than or equal to high. In the first iteration of binary search, we set the trial value of maximum sum as mid value of low and high, which is 34. We call the function minimum number of splits of the list such that none of the splits has sum more than this max sum. We set split count equal to 1 and start filling the first subarray of the list. To begin with, this subarray is empty and its current sum is 0. We process all the elements of the list one by one. First element is 7. If we add this element to current sum, it does not exceed max sum, so we add this element to current sum. Next element is 12. Because 19 does not exceed 34, we add this element also to current sum. Next element is 5 and we add this also to current sum. Next element is 18, but if we add this to current sum, it exceeds max sum, so we do not add it to current sum, but we have to split. For this, we increase split count by 1 and reinitialize current sum equal to the new element for the second subarray. Last element is 8. We add this to the current sum, which becomes 26. We come out of the loop and return split count to the main function. This means that if we fix max sum equal to 34, minimum number of splits of the list is 2, which is less than k, the required number of splits. We save max sum as the minimum largest split sum. In order to increase the number of splits, we must decrease max sum limit for the subarrays. So for the next iteration, we reduce the high fence of binary search to max sum minus 1. In the next iteration of the while loop, we set new value of max sum equal to 25 and call the minimum number of splits once again with max sum equal to 25 this time. First element is 7, which we add to current sum. In the next iteration, we add 12 to current sum. We add 5 also to current sum. At 18, the sum exceeds 25, so we split here by increasing split count by 1 and reinitialize current sum with 18. Adding 8 to current sum, the result exceeds 25, so we make another split and increase split count to 3 and save 8 as the new value of the current sum. The list ends. This time we return 3, which is equal to k, so we save 25 as the new value for minimum largest separate sum and make 24 as the new value of high. In the next iteration of binary search, we set max sum equal to 21 and use it to find minimum number of splits. This time we get 4 splits, which is more than k. This means that max sum has gone too low. So we do not save it, but rather increase low fence of binary search to max sum plus 1. In the next iteration of while loop, max sum becomes 23. This value gives 3 splits, so we save 23 as minimum largest split sum and reduce high to 22. In the next iteration, we set max sum limit as 22, which gives us 4 splits. So we do not change the minimum largest split sum, but increase low to max sum plus 1. With this, we come out of binary search and return 23 as the final value of minimum largest split sum. If n is the length of the array and s is the sum of the integers of the array, then for each bisection of s, we process the list of n elements sequentially. So time complexity is of the order of n log s. Space complexity is constant. Thank you for your time. I hope you liked the video. Please stay tuned for more such interesting videos.